Morning. Rest.
Hello, folks.
Hey, everybody, can you hear me okay?
Yes, I can hear you.
Yeah. Took me twice to join. Okay, cool. Let me see if we get my minutes up. So quick question first. So I got a few things I can share. Did you guys receive, I was trying to still play around with this OCP stuff, make sure I got everything set up right. Did you guys receive minutes? I just sent out just a little bit from last week. Let me see.
Yeah, I just received the minutes.
Okay, good. Yeah, I forgot to send that out, and then I tried that link, and I wanted to make sure because I had Kevin make a few changes. He also put this work group up on the main page. I need to add like a mission statement or something, but at least he put it up on the main what do you call it? Sustainability page, if you will. So that's up there now. And then let me share my notes just for today. There we go. Okay. So he did that as well. And so, okay, good. So I want to make sure of those two things. And then let me just see who's on the call. We also had Edgar join. Oops, maybe now am I sharing my minutes? There we go. Okay. And then yeah, so let's see. We had one new join for the work group as well. Edgar joined during the week. Edgar works at Intel, but Edgar, you want to just introduce yourself really quick?
Yeah. Hi everyone. My name is Edgar Rodriguez or Edgar Arruti. My name is kind of complex. I'm Mexican, so I have a compound last name. So let's leave it at Rodriguez if you want. I work with Danny in the server platform architecture, focus on the power management / energy efficiency domain. I've been in the company for about 12 years now, and I'm based in Oregon in the United States. Not sure if that's good enough, or should I answer something?
Yep, no, that's great.
Okay.
Okay. And then, so I think that's it for like kind of pass downs from before. Before we get into, I think, Shruti, are you still able to take us through some of the stuff that we had talked about like last week or the week before?
Yeah, so I wanted to also a little bit read through your minutes of what was discussed. I was just looking at that.
Yeah, we just had basically myself, Jeff, and then a other new member that he's I don't see him on today, Hashem. So we kind of caught him up on a few things, and then Jeff and I were just kind of brainstorming on some of the next steps and some of the reporting and kind of a little bit of what we talked through at OCP and then a few other things as well.
Okay. So maybe I'll let you finish with noting down your opens and agenda. I'll maybe go over one or two particular points that from my perspective are sort of lacking in the entire power telemetry, and then you can add on to that.
Okay. And yeah, maybe like that. Okay. So before we get into that, is there any opens from anybody else? I don't know if Jeff, you had anything?
No, I didn't.
Okay. Cool. Okay. I think the only other thing I could think of was we're coming up, we got a couple weeks out before the Thanksgiving holiday. Let's see, it's on the 23rd this year. Are you guys in on that week? So it's 1, 2, 3 weeks away. I guess we have two options. We can move it up to like Monday, Tuesday, or something that week. A lot of people also take the whole week off, so I just wanted to see what you guys thought or were doing.
I am Not sure because it is Thursday afternoon. I'm not totally sure, but I would certainly try to call in by phone if nothing else.
Yeah, well, I would move it, if we kept something for that week, I would definitely move it to probably like Monday or Tuesday.
Oh, then I can certainly join.
Okay, Jeff, are you around that week or are you taking the whole week off or?
I'm taking the whole week off, and also just note that the week before is the supercompute conference, so I'll be out for that as well.
Got it. Okay, and then Edgar, are you around that week? I don't know if you're taking any days off that week. I plan to be here, so.
I'm not sure yet, Danny. I'm planning a trip to Mexico, but I still need to figure out if I'm gonna take days or not. It depends on something I need to do down there. Yeah.
Okay, so let's do this. I'll move it. I don't know if anybody is this time slot okay? This Pacific time slot. Daylight savings will be hitting by then as well, but I was thinking of maybe this slot on Monday the 20th. I don't know, Shruti, Edgar, if you're
Only
around.
for that week.
Say again?
Only for that week.
Yeah, just for that week, Monday the 20th at 10 a.m.
Works for me.
Yeah, works. That
Okay.
works.
Yep, I'll throw it there, and then like I said, people's things change, we can do it. But I think that's the only other housekeeping things I have. Okay, cool. Okay, so yeah, I guess let's get going with it. Jen, I don't know, Shruti, if you have any materials you want to share, or do you just want to like walk us through it, or?
I'll use one slide visual. I guess it will be a little bit easier to talk.
Yeah, of course.
So, okay. So within like power measurement and telemetry, right? Like one thing that I was seeing as why is it not showing?
There it is. Okay. Yep. See it now.
Do you see it? Okay. Okay. So one thing that I was sort of thinking as missing in the entire power telemetry measurement aspect is, so currently we have like various levels of measurement, not clearly defined various levels, but there are multiple measurements happening at different levels. There is one aspect of exactly the point of measurement that I know even Sammy's group is looking at, the point of power measurement and the sample rate, etc.
Yeah.
But another aspect that I think is lacking is a consolidated view of all those levels of measurement. And what I mean by that is, so now PUE looks at a DC level view. There are other measurements happening at system level, etc. But there is no combined view that sort of puts together, okay, the DC is showing this power measurement, and that's when these particular systems are showing this power measurement. So that gives a better overall view of how exactly the power is getting utilized, which how much portion of it is actually going into useful, I'll say, equipment versus is going into the supporting equipment. I know PUE is supposed to indicate that, but if we are sort of able to look at DC down to system, down to device level, all in one consolidated view, I think that gives a much better idea of where are the power losses, or in order to encourage sort of being efficient at those points.
Mm-hmm.
So that was one big, I'll say, pain point from my end. The second part is, and I probably didn't write that down also, is this consolidated view together, this being made available to, let's say, like cross team. So there is, for example, one team that's actually running operation of DCs. So there are the direct operators who are running, who will first be able to access this as all of this is being measured. But having that common interface where it is available to be viewed by other hardware, software, all the other teams in that same consolidated view. I have written system utilization and sample rate as important points over here, but not raising those because Sammy's group is basically discussing these particular aspects of the PUE measurement.
Okay. Okay, so you're saying the other utilization. Okay. I mean, are they planning to use redfish as well, or they're still working through it?
So they are not, and this is, my understanding till now. I think I've been a part of most of their conversations. So they are not looking at how the power measurement would be viewed or conveyed. So they are not looking at those aspects.
Mm-hmm.
They are just looking at the, how would the measurement be taken?
Okay.
Does that make sense? So they do mention utilization or workload or system utilization because that context is essential during the measurement. So they mention it in the sense that when the measurement is taken, the workload percentage or the utilization percentage needs to be stated, or that basically tells what category of measurement this is. So in that sense, they mention the system utilization, but they are not concentrating on sort of how all of this data is going to come together or be viewed together or be conveyed together.
Okay. Okay. So let's maybe do this. I don't know if you have slides to it, but we can maybe just kind of talk through it. And this is one of the things that we discussed last week. So I guess focusing first on system level, right? Kind of nailing that down. And one of the things that we did talk about, and Jeff kind of I think answered this, which was basically, I went through and checked like, oh, does the the other specs like for the was it DCMHS spec for like the boards and stuff, do they have anything on telemetry, power telemetry? They didn't. And Jeff was basically saying that if we define the expectations here, and then via this work group and the manageability work group, it can then basically be asks and requirements set of all the other hardware, right? And that's kind of how we'll progress. And I think that makes a lot of sense. But if we want to start at the system level, I guess kind of two questions to you, like, what are the current expectations of what, you guys are monitoring? Are you expanding that? Are you changing it? Or what do what would be your recommendations? And then we were also going back and forth between, we're basically settling on saying, it seems to make the most sense to report energy and then have the aggregation and conversion to watts sort of along the way, if you will, right? Whatever is going to be monitoring that, is keeping track of the timestamps and doing the conversion there. But I was curious, is that the way, you're reporting, your device or component level, power readings? Is that how you get to them?
When you say you want to actually measure energy, you're saying you're not measuring in watts?
No, usually like a lot of times for some of the things it'll just be reporting joules, and then
Okay.
if you know how long between your samples, and if it gets accumulated, right, just doing the math there. But I wasn't sure if that's how it works so far as your systems, or what's useful for you, or if you found it's easier to convert earlier, or...
Yeah. So it's really just a scale of units, right? So
Yeah.
at very small levels, you might do it in joules, but a joule is a watt second. So at larger scales, that the energy measurements usually come out in kilowatt hour, or either watt hours or kilowatt hours.
Yeah, generally, like I agree with that. Like, even if the actual measurement is in joules, I think, at least from my point of view, very quickly it is, watt hours or kilowatt hours, and sort of used in that sense.
Yeah, because you're counting up, if you're counting up joules, you're getting, you're going to get into thousands of joules after just a few seconds.
Right.
For any device that's doing anything interesting, right? So I mean, a 1 watt device running for a second is 60 joules.
And
Why does it?
Well, go ahead.
No, I was going to understand why were you saying that is important? Like, why did you want to keep the measurement in joules or as energy?
That's a good point. I'm trying to think if there's, and then yeah, I'm actually going back. I'm not sure if there's a big reason to do it in one versus the other.
Well, it's not the units aren't the issue because it's all the same units. It's just a matter of scale. I mean, this is arithmetic, not it's not metric versus something else, but it's really the measurement of energy as opposed to the measurement of power. Because power is an instantaneous is a rate, not an actual consumption. We colloquially term I'm reading my power meter. Well, you're not being billed for your rate of energy consumption. You're being billed for how much energy you consumed.
Totally.
So it's really on your house you're getting charged for energy consumption, not power consumption. So it's an English or vernacular kind of problem. But the difference being that from a again, we're not interested in the rates. We want to know what the totals are. And the other thing is that since energy consumption is typically a counter, it allows us to run at much lower sampling rates because I don't lose data. As long as as long as I don't care how much energy I used over the last 5 minutes, I can just come and look at the end of the 5 minutes and get the total. And 5 minutes is probably really granular for any kind of actual movement of things and making decisions. So it's probably more like hours or days. But again, I don't lose any data as long as I don't roll over a counter somewhere. Because I can come back in an hour and find out exactly how much energy I consumed over that hour, whether that happened, whether that was a very lumpy consumption or whether it was a really, flat level over that hour. The energy count is the same.
And that, I mean, yeah, that is critical, right? I think because then if we set it as just these, energy counters are running, we need to understand and set, it'll flow into device specs basically for how long these counters need to be, or the expectation of how often they're read. And I guess every time they're read, they're reset, right?
They don't have to be. I mean, it all, that's up to the implementation. I think generally we like to say that the counter should reset, given some application input. In Redfish, the counters don't reset unless a user actually specifically tells it to. Because the counters tend to be largish, so it's like, well, I can come back tomorrow and I can do the math, right? So if you keep resetting it, then I've lost. If I'm not reading it, then I've lost it, right? So your utility meter on your house never resets. It continues to count upwards, and you just get billed from the time when your meter was last read versus today.
Yeah, just that delta.
Yep.
I'm going to pause the share because I can't see who's talking. Yes, sorry.
Oh, there we go. Cool. And I can put my camera on too. What was I going to say? So yeah, so actually I captured another one, and then I can go back and just share my notes as we all kind of go through this. But let me see here. I can go back to finding. I know that's the hard part when you share, you like lose everything. Can't see anything. Let me go back and share my screen. So you just reminded me another one, which is sort of periodicity too. So okay, so if we go back, we'll keep working on this one then. So power versus energy. So I think like you said, we'll have the expectation that it's energy, right? And that those units will flow through. That's pretty okay. You're saying Redfish also has commands already in there, so far as like asking the counter to reset or not?
Correct.
Okay. Okay.
Yeah, and it records the reset time as well.
Okay.
Jeff, are you saying a lot of the hardware specs that we have, they do not cover telemetry related to power?
Or
I don't know, somebody mentioned something like
Yeah,
that.
the OCP, yeah, that was me. So that, and that was kind of, I think Jeff answered that too. And I looked around and I talked to a few people. Yeah, like the DCMHS spec, kind of the main spec. Like I searched through it. It's this huge old like 700-page document, and I couldn't find anything on telemetry. And I asked Brian Aspis, who's one of the Intel folks who works on that committee, and he says, yeah, there's nothing that he could think of that specifies like these devices shall report power and in this way or anything. There's just nothing there at all.
Okay.
But essentially we would be the forcing function to make that happen at whatever level and specs.
Okay.
Yeah, I think the capabilities are all there, but it's the actual prescriptive requirements are not.
Yeah.
Right.
Okay.
With respect to drives, well, I guess there is some understanding of power in drive telemetry, although I agree, not good enough, I guess.
So
We talk
you
about like
could say,
storage
like,
drives.
yeah, so let's say like devices, right? So I think we break them out. So there'd be like storage, network. Let me go back up here and put more like system components. So like fans. So today, if I had to look at this, I think this is a pretty good expectation. I don't know if any CPUs that don't, but I mean, this is done. I'm trying to think how detailed we want to get, right? So this is sort of like, I think CPUs are there. Memory is there. This is actually, as far as I know, this is reported via the CPU. At least as far as I could tell, it's actually read. Yeah, because Edgar, that's correct, right? Basically, we just reading, the BMC is just reading CPU MSRs and Becky commands to get out the memories. Yeah.
Yeah, that's perfect. Yeah.
Yeah, so that's kind of interesting. So that one, so it's actually reported by the CPU. And there's a little bit of nuance here because in DDR4 versus 5, the VRIMON is now on the DIMM. And so I'm just,
And the PMIC itself reports energy consumption.
right.
So that all should go to the PM bus and should be available for the BMC.
Yeah. And again, this is where we, eventually we don't have to go solve all this, but just worth noting. Either way, so that would, I mean, basically this would be an expectation of the CPU, right? That it's going to be required to report memory power as well. I don't think there's anything else CPU does. It's just that, those two. Okay. Fans today, I've only seen, I don't know, Jeff, you've seen different, but fan speed is reported.
Right.
Instead of, and not, we don't have the energy there. So I guess the ask would be that this would almost be like for it, in order to have insight into energy, a separate device I think is needed.
And then all of these, when we are saying reported, are we thinking of, the instantaneous power reported? Or like, in what duration, or is it an average, or what are we thinking should be reported here?
Right. Yeah. And that's the thing. I think for all these it's going back to energy, right? So CPU reports energy. So it doesn't report the, like Jeff said, doesn't report the rate. It actually reports, it has an energy counter. Actually, I should go look. I think that's the way. Yeah, and then it must be the BMC code that's doing the conversion to watts when you get it when you're reading basically SM bus, BM bus.
Yeah.
With
Because you get
IPMI or
watts.
Redfish or anything, it's the BMC which is doing the math today.
Correct.
Yeah, doing that math. So this is okay. So that's done. That's done. This would basically this would be our ask, right? I think we would want is reported. We would want this to want this to continue because I think this is just really valuable. It's part of like fan tuning and all that.
Yeah, it is, but I want to be careful there because I think what we care about there is the fans as a subsystem. And that's what we've put in the Redfish spec for reporting that was like at the the thermal subsystem level. Because I don't want to start placing requirements on individual fan readings because that is going to be additional circuitry. So whether somebody does that or not, it's one thing, but I don't want to start making requirements for that because we don't need to know what each individual fan is driving. That's a design time decision, but we want to know at least at a whole, how much power is going to the fans.
You're saying like, yeah, because you're right. There could be like, I mean, technically there's a fan within the PSU. I mean, even
Right.
like a Silverbox PSU has its own little fan. So maybe just like, the large chassis cooling fans.
I mean, because what we're trying to get out of this is that I'm going to total up all the fans in the system, and in terms of what I'm trying to get to is that's the ITUE stuff, right? So I want to know what power is being wasted on fans spinning versus compute. So I don't need, whether the BMC is doing the arithmetic to go add up the different values it found or looking it up at the various tables to figure it out. I don't want to start driving hardware requirements to go like, hey, I need to go add a power monitor chip on every fan just to get the fan power so that I can take it and then sum it, right? So let's not, this is the kind of stuff that drives our hardware guys crazy and makes them not do what we need. But it's like, I just added $5 to this,
Yeah. So and certainly that's one thing it's a pretty good relationship, fan speed to energy. So, and that's not very hard to put in there. So why not have the BMC? Basically, we're just having an expectation of the manageability specs that's going to be, yeah.
Yeah, but now that said, they are absolutely related, but it's not something you can get with a single equation because it will depend on it's obviously at first it's not linear, right? Fan running at 100% versus 50% is consuming more than twice the power, but it's also an in situ measurement because it's going to depend on pressures.
Yep. Yeah. Pressure's yeah, exactly. That's the big one. And I don't think.
But again, nothing the user can do about that. So it's like, hey, if I can just get the total summation, that's good enough for what we need. So
yeah, I mean,
let's not drive more requirements than what's necessary.
Yeah, and even I'd have to think back, but even memory is a little bit like that, right? Because I think the current monitoring that gets used for it isn't all of the DIMM power. So it's,
the difference there is that there's a lot of, and obviously CPU is clearly, CPU, GPUs, that's clearly, you want to know individuals because that's how you're going to go, look at workloads and other things that we may be enabling. Memory, I think that, it may be that we only get it for, depending on what generation of product we're looking at, we may only get it kind of at the total levels. But I think you would want to say, let's at least talk about it at a per device level because especially as we get to different types of memory, right? If I've got a mix of DIMM and NVDIMM, the power of that's going to be very different.
Yeah, and but okay, I see what you're saying.
Right. So I mean, and I don't know how you write that up, or I mean, I don't know how you would do it in hardware to say like, oh well, I'm not going to total up all my DIMMs and give you another total for all the NVDIMMs. I'm going to report it, per device, and then you're gonna, if you want to sort that out, then you can divide the 8 into the 4 and 4 or the 6 and the 2 or whatever.
Yeah. Okay.
So just thinking out loud, do you need the energy or power at a per DIMM level? So right now it's looking at not per DIMM but the memory attached to the CPU.
You're saying, so your first question is, do we need it on a per DIMM basis?
Yeah.
I mean, I think some people would definitely want it on that. The people that are eventually wanting to have like public cloud and be like, this workload's on this DIM, this workload's on that DIM. Yeah, and that would mean so that basically we're placing requirements on the CPU to make sure that that's again estimated and correctly. Because I don't know if it's I'm trying to think if I guess for DDR5, every DIMM's IMON is kept separate. There shouldn't be any reason why you can't. Before that, it gets more complicated, but yeah. So I'll just put it right here, per DIM level. And then, and because I think today, if I had I don't know, Edgar, you might know too. I think it's actually broken out like on a per memory controller basis. Like this is the power of all the DIMMs on this memory controller. And it just depends. I think that's what it is today, actually. But
yeah,
like,
you're right.
Yeah. But that's something that this would drive change, right? Now we would expect CPUs to report on a per DIM level, channel this, is this much power, channel this.
Which can be done since the DIM itself has a PMIC right now, and each one of them have the capability.
Yeah. On aggregated. At least this is again kind of an Intel CPU statement. I don't know how others do it.
Aggregated, like each controller level.
Yeah, like you have two memory controllers for a CPU, and so and then you have, I don't know, 8 channels on that CPU. You're basically getting 4 of the channels reported as one energy, and then the other 4 DIMMs, the other channel report. That's kind of how I know Intel's doing it for at least a couple of generations. And then the difference that DDR5, and I'll just put in the notes for those who want to say, so DDR5 has IMON on DIM. So the current monitor, that sort of VR monitoring, the VR's on the DIM, the IMON's on there, and then that gets reported back to the CPU, but at least that per DIM level current monitoring is there to be used for the power calculation. Okay.
Also, so within the memory section, so a little bit forward looking, because there is quite a bit work and effort on having CXL, and one part is that memory attached via CXL. And then that changes, I think that would change CPU's ability to be able to understand what is the 4 DIM power. So if I had CXL and then 4 DIMs attached after that, maybe something we want to look at.
Yeah. Okay, I can check on that. I'll kind of tag. Let me ask. I think it's passed along as part of the protocol, but I'm actually not sure if there's any differences. So that's a good question. Okay, so those are the main ones, and then I think after that we go through storage. So we go through kind of these. I think so far as, I mean, devices, everything's either going to be via PCIe or CXL. But I think I'm just thinking, I mean, is it that, I mean, I guess here, I don't know, Jeff, at this level, are we basically just saying that because PCIe and CXL have a way to communicate with the system management bus, the power management bus. And basically, as long as it's putting it out on there, and then we require the devices to put it on there, is there anything else that's really it, right? I mean,
yeah, and again, I want to be careful about what we start, prescribing out, because I think for this group, it's the stuff that's going to be the high dynamic, the places where we have good chances to push energy efficiency, and then the ITUE distinctions, right? So yeah, stuff like the CXL devices, like they certainly have the ability to but I don't know how far we want to take that from as a requirement thing, right?
Mm-hmm.
Because I would expect that that all the power being consumed by all the PCIe devices, that all goes into the it goes all into the useful work bucket, so to speak.
Yeah, it does. And then I guess, but then the sort of like, are we, and I guess, and certainly the ideal case is that any device, any PCIe, any CXL attached device reports its energy. I think that's kind of the easy statement. Or is it that we ask this of sort of the platform, right? That, you know what's going out, you know what those 12-volt rails are putting out, but then okay. So I guess there's really kind of two options, right? So either device.
Well, and remember, we're certainly getting the energy consumption at the entire platform level. So some of this can also be subtractive, right? So if I start looking at things that have big impacts on the overall consumption or the efficiency, and that's really the CPU, GPU, full stop. Everything else is probably fairly static or heavily dependent on that. And so that's why let's make sure we get the aggregate fan power, so because we know that's going to be waste heat, so to speak. Well, it's all waste, but we know that's not applying to the compute efficiency. But all the PCI devices and everything else, the chipset and everything else that's powering that CPU memory complex, is all going to come out in the total platform power.
Yeah. So so then we've got, and you kind of capture it there. So then we also have, we have these components, and then we have, okay, so let me see. So PSU, so if we have a silver box PSU enabled systems, right? They report, these report DC power, AC power, or I guess, yeah, they're probably, I don't know if they're reporting energy or power, but they have the ability to obviously report the DC energy. So sort of like, like you said, we can capture all the other components, right? In here and in here, right? Then now we have the BNC do the math to subtract it off. But for let's say like DC bus bar systems, right? I don't know. Is there anything? Have you seen anything, Jeff, where like there's a separate like power sensor or something on that main rail, like where? Because yeah, once you're out of the system, it has to be on this side, or it has to be at the system level.
Yeah. So I haven't looked specifically at all of them, but and I hate to give it a depends answer, but it's either at the power shelf is providing that at the aggregate for the whole rack, everything that's attached to the bus bar, or if the server design was intended to be flexible for either AC or DC, then it would have the same line measurements. They'll just be in DC coming off the bus bar. So the power, there's still a PSU, so to speak. It's just not. It just doesn't have the. It's not doing all the AC conversions.
Basically, it's part of the PDB, like the power delivery block.
It's gonna depend on whether that's a dedicated design for intended for bus bars or DC only, or if it's a more general purpose platform that has AC or DC capability. I would expect that the DC dedicated systems would still have a measurement point there, because because they're certainly doing internal conversions even from 48, because they're still got to get to 3, 5, and 12, right? So I hope that largest converter would still have the same PM bus kind of specs.
Yeah, I guess you're right. There's a few places, right? Let me see here. Yeah, but typically, so kind of two thoughts, right? So you're one saying like, yeah, so we got to do all the VR conversions, but typically, or I would say most of those VRs probably aren't going to be VR like 13, 14, 15 that have IMON. They might just be a pretty simple VR, especially if it's just powering small things. Because I'm trying to think like there's sort of two ways that rest of system, or I guess the total system, and then from that we would calculate the rest of system would get reported, and it could be that the PDB has again, a current sensor, a voltage sensor, and does the math and itself does the reporting out to PM bus, or if that data is sent to the CPU, kind of like memory, then it's like, oh, the CPU reports on its behalf, it does the math and says, okay, here's the energy. There's sort of two ways. And I know like, basically our Intel systems would do something like that, right? Like we have a sensor there that we use for stuff, for platform level power capping. That's part of like, but that's again, part of like an Intel feature. I don't know. But as a general kind of, again, OCP spec of like, either, and maybe it's left open as options, but like the platform, there should be some way that rest of platform can be calculated, right? Otherwise, we're always going to have this like, missing amount. We want to, basically be kind of lossless in our methodology. We might not be able to 100% attribute, but there shouldn't be energy that's like unaccounted for, right? So this might be something where we leave some, or a lot of kind of hardware freedoms, but just that's kind of where we leave it, is there, that's the expectation, right? Energy can be derived. Okay, that one might be lead to some more stuff with some other work groups later, but okay. So let's see here. I'm going to do it this way, rest of platform. So we've got 10 of 2 solutions there. Okay. So is this the level that I'm trying to, I think, I don't know my take, but I think GPUs, accelerators, I don't know if there's anything else we want to bump into there. I actually think these are such big power devices. I think we want to like basically ask these things to like report it, make it an expectation that they report energy.
Yeah, well, I mean,
I think they
certainly they're certainly on the same order of magnitude as the CPU, right? So any requirements we're putting on the CPU should be on the GPU.
Yeah, exactly. Network isn't. Oh, go ahead.
GPU should have similar power sort of reporting already also.
Yeah, I think they all do, but be good to just nail that down. Networking equipment is a little, I guess, I mean, do we see, I mean, is there any reason not to impose this on them? Like, trying to think.
Yeah, it's a tough one, because again, it's really at that adapter levels, and they certainly haven't had those. I mean, the places you see that that getting reported today is usually at the transceivers, because they have their their transmit receive power stuff. So those are actual settings, and so they may have those. And I assume that if I'm setting something to, and I'm not going to try to make up a number, but I set it to whatever output power level, that's probably what it's consuming, because otherwise why would you have that setting? So that's probably that's probably reasonably sufficient, but getting more than that, I don't know how variable those loads tend to be. They can be non-trivial, right? They can be consuming a considerable amount of power, but again, probably gets dwarfed by the GPU. But if it's a network switch, well, then you got a lot of that. But I mean, I don't know how variable that gets. Is that if I'm if I'm sending, ones and zeros, alternating over and over again, is that how much is that driving consumption versus all zeros or whatever? Yeah, I don't know. So that's where we get into the let's make sure that we're not adding the hardware costs for everything, and also the power consumption of the measurement, right? So it's let's not make them measure stuff that drives up the consumption either.
So
Exactly.
one thing for both of these, so I agree that it's a lot workload dependent. So it's sort of dependent upon what is going on with the GPU or the CPU sort of utilizing these components. And maybe it could be spec managed, similar to fans, like in the sense that we sort of have an idea of at this particular workload or utilization, this is the power that it is using. Maybe it could be spec managed that way. I do see one thing, that although for a single device, it might be dwarfed by what the GPU or CPU is consuming, but then depending upon how the system it might add up if there are a number of, like for example, storage devices in that system. So in that sense, we may not, on one device level, it might be very small, but I know at least storage many of the storage devices get packed in, so it might be more than.
Yeah, and actually you kind of reminded me of maybe we put this up here, which is like expectations for reporting energy by power state. So and we actually kind of both hit this. So active, it's sort of a yes, no brainer. And then the question is if it's in power manage, right? So let's say it's like D1, do we are we still asking it to report power when we let's say like a device is in D1 state, right? It's in like a state basically.
And it could be spec
one, yeah.
It could be spec managed based on these states also, like for these
devices. Right. Exactly. Like maybe the way we handle it is simply like, look, this device is in a low power state. We don't want to have power telemetry waking it up all the time. Like we've seen this a lot, just to report its power being low. And then it wakes it up to do that and actually increases the power. Right. Maybe just say, look, once a device is in a state, in the BMC or as part of the Redfish protocol, we have in there, hey, this preloaded device state consumes this much power, right? That becomes, that's another option, sort of like the way we've been talking about handling fans, right?
Yeah.
Okay.
Yeah.
And that means it's a spec. Sorry, go ahead.
Yeah. And an important piece there is that there's a if you're in a very low power state, yeah, I don't want you to wake up to tell me that you're in a low power state, but you're not off, so you are still consuming. So I do expect you to continue counting. Whether or not you can report that, it may not be you can't tell me that you've been consuming 5 watts overnight. But in the morning, when I look at my energy consumption, I should see that, versus the measurement that I got back at, 10 p.m. when I read it again at 7 a.m., there's a difference of 5 watts because because you were running in low power all night. But, I want to be able to still compare that to my electric meter, especially when it's not in zero, right? So.
Mm-hmm. On, I don't know, saved power.
Thanks, Edgar.
Yeah, and that's, so it could be just that too. Like, I guess if they're in this state, so how does that work? So if you have a device and let's say the IO is in L1, right? Like again, like some PCIe device, it's basically in D1. You take the link down, that actually saves CPU power as well. That's all good stuff. But then, like you said, you haven't looked at it for a day and you want to just go read the accumulated energy.
Mm-hmm.
Does that bring it? Because it's not, I guess.
If it's
I
if
mean,
it's
I guess
measuring accumulated energy, it better be measuring accumulated energy, right? So
right, it's measuring it, but does it bring it out of D1 to do that, or can it stay in that D1 state? And like, I don't want to have that link come all the way back up, because that definitely brings up a
I'm
lot.
assuming when you're saying D1, you're talking about devices like storage network.
Yeah.
Like right now, and
Yeah, the device in
maybe I'm
D1,
forgetting, but we don't
and then the IO link would also come out of L1, right? And like this
report
would
it.
be power, and then this would be more power, and then it would even cause the CPU to have power go up. So
Yeah.
I'm like, I wonder if we can just via the PM bus link to PCIe get that value, get that accumulated energy without waking those other things up.
Right now, they don't have an accumulated energy counter, right? Correct me if I'm forgetting.
I don't know. I think it's I think there might be some devices that do, but I'm not sure. That's I think, and I'm sure there's many that don't. But I think the question is, if we're adding that as an expectation kind of going forward as a, I don't know, optional or very much a nice to have, whatever, because otherwise then it just goes into rest of platform, right? So there's always a bucket, but there's sort of like we would like it to be, because like you said, this could add up. And then to this nuance of like being in a power managed state, is there a, I mean, I guess this then becomes almost like a, is this becoming like a pecky spec expectation that like you can read accumulated energy without exiting a power management state? I don't know if that's.
I think my question is taking one step back. Like if we are saying that its power reporting can be spec managed, like sort of understanding that this power state is so much power,
Yep.
then need a continuously logging counter for energy in there.
Oh, do we still need it, you're saying?
Yeah, we still need it because then essentially we just need to see the history of its power states and the rest of it is spec managed.
It's a good point. Yeah, that's true.
And I'm just trying to, because I think they do not right now log energy as a continuous running counter. So I'm just trying to not introduce new things if we are managing it in
Exactly. Via a spec definition. Yeah, I don't know, Jeff, any reason you could think of why? Like if when it comes back up again, you check it and compare, or?
Yeah. Yeah, I mean that I think that's all the expectation is that look, things are in their lowest power states. You may not, you're not going to get any reporting, and so don't ask. But somebody needs to account for that. And again, it may be that like, hey, I'm not going to get the individual those individual counters. They may reset every time you go into an L1 state, right? So. So that's fine, but at the platform level, somebody's going to account for that, but and then they have to start counting again.
Yeah,
I agree. At the platform level, we have to account for that, knowing that they went into D1.
okay. So we'll have to note that. So I'll put the notes about that. Okay, so we're gonna say all devices. Well, anyway, I'll kind of keep the notes like that, but I think that's a good thing for, could apply to many devices, right? We don't want to be waking them up just to report little power, little energy. Okay, let's see. We only got about 5 minutes left. So again, trying to focus anything we've missed on system, right? So we sort of CPU, we have memory, we have chassis, we have devices. We've talked a little bit about some types of devices, what are kind of must-haves, what we think could be managed by specs, a little bit about rest of platform and some nuances. Anything that we're missing at a system level, because that's definitely step one.
So, yeah, there's one more thing in my mind. And this question has come up off and on in different discussions. Sometimes folks want like some kind of a criteria on what's going to be the difference in the power level between active and idle states for the device, like a percentage difference. do we want to consider any guidelines for that, for each type of device?
Meaning like specifying how low device power must be in a power managed state? Is that what you're saying?
Percentage-wise, how much lower compared to its active state? Not an absolute number, obviously, because it will be different for different devices.
Yeah, I mean, it's a good conversation. It probably is outside of the telemetry work group. Yeah, I mean, especially if we say that once you're in power manage, I mean, basically, so far as telemetry, so I guess when it becomes active, so Jeff, is there, when it comes to Redfish protocols, is there profiles? Is it basically that like all the parameters are always being reported, or are there some things that get kind of loaded at boot, loaded once, and then not read again? For example, I'm this device, here's my D1 power. You really only need to say that once. Does that happen that way, or does it always just, hey, I'm always sending this data every time as part of my bunch of packets?
Short answer is it's always reported if it's available. But when you say sending, it's like, well, in terms of like what gets transmitted for like telemetry and stuff, yeah, you don't send all the static resources. But if I come and look at the processor details, yeah, you would get all those ratings as well as the dynamic data. The model tries to make that efficient by dividing those things up. So, I come ask for effectively like, here's all the static information about the processor, and then there's a processor metrics resource that has the more dynamic stuff. So you tend to like go get that once and then go get these things, more often.
Okay, that's how we'd handle it. Okay. Yeah, but did that, I guess that was the only thing I think, but did that make sense, Shruti, that maybe, is that what you're going to, like, if we're going to tackle like expectations for how power efficient things need to be, or?
That is what I was thinking, but your point does make sense that it's not a guideline for how the data is being collected or where it's being collected.
Yeah.
It's about what the value is. So
yeah.
maybe
Although collecting it will certainly start driving the behavior that you want, which is like all of a sudden, if everybody's like, oh, I need a report, like not just like have it buried in some spec somewhere or have it available when a customer asks, but like, oh, wow, like anybody that just connects this up to any server is going to be able to read this really quickly. I think, this is what we all want so far as sustainability. I think that will drive that behavior, right? But yeah. Okay. Let me see. So we're at time. I think we covered system pretty well. I'll send these minutes out now that I know the link all works. There's a couple of things to track down, maybe some devices. I guess shoot me a note during the week if you guys have a specific agenda item. I think we probably are going to want one other pass at this as we go through it, especially like some of these device questions. I might want to talk to a few people if I get a chance. And then the only other things we might talk about are things like, do we set expectations on periodicity? Temperature is one of these things that we've talked about, even though we're kind of the power telemetry work group, it's like goes hand in hand. And then otherwise, we could start, maybe going, outside of the compute system, right? And figuring like, what's the order that we want to tackle stuff like liquid cooling or, other things like storage or something. So, okay. Okay, cool. Well, let me send these out and then, yeah, you guys send me stuff during the week or just send an email to the whole group so everybody can see. And then we'll meet next week and then I'll go move that Thanksgiving week meeting as well. Cool. All right, you guys. Thanks again.
Thank
I'll
you.
see you later.
Bye-bye.